Okay, people, let's keep on working. This time I'm solving for you the exercises for which you were given the names and for which you have to sketch out the structures. Exercise that, as we've said, is much more easily solved. Okay, in the very first exercise, I gave you this name, D, parentheses, 2, 3, dibromo, 2,3-hydroxy, 2,3-hydroxy, Xyl, you close the parentheses, and you have the word ether. Let's analyze the exercise. First thing, go to the end of the name, and there you see that this compound is an ether, and an ether means an oxygen that you're splitting the molecule from the oxygen onto both sides, and for which you're having the R's, the radicals. These radicals can be the same or they can be different. How to know if they're the same or they are different? Just check it out. If it says D, whatever the name of the radicals, this is meaning that you have two of the same type. Now that you've identified this, go to the ending part of the name for the branches, and there you'll see it says Xyl. What does this mean? This is meaning that you will be having to write 6 carbon atoms to the right, 6 carbon atoms to the left. 1, 2, 3, 4, 5, 6. This is an Xyl. And we're doing the very same thing onto the other side. 1, 2, 3, 4, 5, and 6. Okay, which one is carbon 1 in each one of the branches? The carbon atom attached directly to the oxygen. This is carbon 1. This is carbon 1 for each one of the R branches. And it says that you have at 2, 3, in carbon atom number 2, carbon atom number 3, carbon atom number 2, carbon atom number 3. We're doing the very same thing onto both sides. You have 2 bromos. I'm erasing the numbers now so that you can see, and the Xyl, so that you can see where am I going to be placing my bromos. I'm placing carbon 2, let me erase this completely and rewrite this C. Okay, you're placing in carbon 2 and carbon 3, 2 bromos. Let's do the very same thing onto the other side. A bromo on carbon atom number 3, a bromo on carbon atom number 3. Then it says 2,3 hydroxy, meaning that now you have a hydroxy over here, carbon 2, a hydroxy over here, carbon 3. And you're doing the very same thing on the other branch. That's at the end of the name for the branches. The only thing that we needed to do now is to complete the tetravalencies. 1, 2, 3, 4, this is complete. 1, 2, 3, 4, this is complete. So you need an H2, an H2, an H3, and an H2 over here. Let me clear this out so as to make it erasing also the R. You have your first carbon atom, which is a CH2, carbon 1, 2, 3, 4, 5, and 6. I'm erasing the R also on this side. I'll erase the complete C and I'll rewrite it. Here you have this C, for which you're completing its tetravalency with these two hydrogens. This carbon atom has its 4 bonds. This carbon atom has its 4 bonds. And I'm completing the tetravalency of these other 2 carbon atoms. This is the compound that you should have sketched. Easy, right? Let's move on to the following. It says 3 hydroxy pentanal. As always, go to the last part of the name of the given compound. It's a pent, 5 carbon atoms, 2, 3, 4, 5. It's a pentane, single bonds, and it's an aldehyde. So therefore, either on this carbon atom or on this one, the one that you will be deciding for it to be carbon atom number 1, you are adding the carbonyl group. But if the carbonyl group is on the end of the compound, in order to complete its tetravalency, we have to add a hydrogen. So this is my carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. And it says 3 hydroxy. This means that in our carbon atom number 3, you are adding an OH, and you are completing the tetravalencies. To the question, could you have sketched this compound in a skeletal manner? The answer is yes, of course. 1, 2, 3, 4, 5 carbon atoms. If this is going to be my carbon atom number 1, I'm adding the O. I don't need to add the H here, but if it would be clearer for you, well, let's have it there. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. For carbon atom number 3, add an OH radical. Easy, right? Let's move on. I'm erasing everything. Okay. The third exercise, it says sec-butyl isopropyl ketone. Remember that if you have the name or the word ketone, this is meaning kind of similar to the ethers where you split the molecule into half, one side, the other side, the 2 branches. What I'm saying, the ether split up and having both of the branches. Well, very similar to that, we can work when having ketones, but this time you place your carbonyl group that makes the ketone be there, and you're placing onto both sides of the molecule the corresponding branches. We have a sec-butyl and an isopropyl. Onto what side are you placing each one of them? It doesn't matter. You just put them there. Sec-butyl, 4 carbon atoms. The first carbon atom being a secondary carbon. CH2, CH3, and I'm completing the tetravalency of this carbon number 1, which is the secondary type of carbon. I'm adding an H into it so as to make it clear. Let me erase these. And let me add my CH2, CH, from which this CH3 is gonna be hanging out. 1, 2, the bond with the hydrogen 3, 4 bonds for this carbon. Second butyl. To the other side, you're being asked to place an isopropyl. Isopropyl is a branch containing 3 carbon atoms, for which you have 2 sides that are identical, isosceles triangle, CH3, CH3, and you complete the tetravalency. 1, 2, 3, 4 bonds. Don't be confused. This is a single bond. All right, that's the sec-butyl isopropyl ketone. By the way, if we were thinking about this having or not the correct name, the correct order of these 2 branches should have been first placing the isopropyl, which is less complex than the sec-butyl, and then adding the word ketone. Or also be focused on the following. You could have selected the longest continuous hydrocarbon chain that contains the most complex functional group within it. We want the most complex functional group to be on the smallest possible position, carbon 1, 2, 3, because if we were counting onto the opposite position, this would be 1, 2, 3, and the ketone would be sitting on carbon atom number 4. Giving the name to this would be a 2-methyl. Sorry. We have 2 methyls. Sorry. We have this CH3 here, this branch, and you also have this one. So the name of my compound would have been 2, 4 dimethyl 3 hexanone. Hexan, 6 carbon atoms in an X, and it's an alkane. One, it's a ketone. This name is the UPAC name for the compound. This way of naming it is the what was that? Well, the common name for the compound. I forgot this other naming system. Okay, let's move on. I'm erasing everything once again. The very last compound, it says 4, 5 diene 8 nonine diol 2,7. Okay. This 8 over here is giving the position for the ine. These 2, 7 are giving the position for the hydroxyl groups in your alcohol. And as we read the complete name in the last word, this is 9 carbon atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's change the color for this. Okay. If this is going to be carbon 1 and this is going to be carbon 9, on carbon number 2 and number 7, you are adding, hanging from the chain, 2 OH, which make this compound be an alcohol. You are adding the ine on position 8. You are adding 2 ines in carbon 4 and carbon 5. And as for the rest, you just complete the tetravalence: CH3, CH, CH2, CH. Sorry, we cannot place this hydrogen here because you've already got 1, 2, 3, 4. No, yes, sorry. Yes, I'm adding this hydrogen here, not for this carbon atom, which has already got its 4 bonds. You're adding 1 hydrogen here, 1 hydrogen here, no hydrogens to this carbon, which has already completed its 1, 2, 3, 4 chemical bonds, and only 1 hydrogen, for this carbon, so that it will be completing its tetravalence. And then now you have your 4, 5 D-ine, 8, no 9, DO. And that's it. It was really easy. You should have got an excellent grade on these 5 exercises. Thank you.